So we know that the derivative of e to the x is just itself, e to the x. This is something we learned earlier. But what about the other bases? In other words, what about y equals a to the x? What about the derivative of that? Well, let's take what we know about e and see if we can apply it here. So let's do this. Let's write a to the x this way. Let's write it as e to the natural log of a to the x. And since e and natural log are inverses of each other, this e to the natural log a to the x is just exactly equal to a to the x. Now I want to use a property of logs that says that I can bring this x out front like that. See? Just brought the x out front. Now I want to differentiate. So here I go. I'm going to say dy dx. dy dx, well, let's see here. We take the derivative of the outside, which is e, the e part, okay, and now times the derivative of the top, the inside. Well, log a is just a constant, so this is just like taking the derivative of 2x, right? It would just be 2. Well, log ax, like this, is just going to be log a. It's just like the derivative of 3x is 3, the derivative of 4x is 4, the derivative of log ax is log a. So here's what we have so far. So let's take a minute and see if we can rewrite this. This right here, you know, I can put it back in the form that I had, bring the x back up top, and I have log a. Now notice e to the log a to the x. Remember, we already said that that is a to the x, and then we have log a. Well, there it is. There it is. So what we've got is dy dx is equal to a to the x log a. So let's see how this works. Let's suppose that we've got y equals 2 to the x. Well, dy dx is going to equal 2 to the x times log 2. See? Just like that. And of course, the chain rule is involved. We'll still have to use the chain rule. So for example, let's suppose that we want the derivative of 3 to the x squared, something like that. Okay, so we still take the derivative of the exponential part. That's going to be 3 to the x squared log 3. See, just using this formula right here. Now times the derivative of the top, which is 2x. And there we have the derivative. Now let's look at logs. We know that the derivative of the natural log is 1 over x. What we want to do is we want to explore, okay, well, what is the derivative of a log just with a general base a? Well, let's do this. Let's convert this to exponential form because we just learned what the derivative of an exponential function is. So let's go ahead and convert this. So we've got a to the y equals x. Just converted that to exponential form. Now let's implicitly differentiate. So I'm going to implicitly differentiate the left side. I've got a to the y log a. But remember, we've got y up here, so we have to tack on dy dx. And then the derivative of x is just 1. Now remember, I'm trying to find dy dx, so I just divide by the coefficient here, and I get that dy dx is equal to 1 over a to the y log a. Yeah. Now, a to the y, of course, is just x, see, from right here. So this is x log a. Now notice that's a lot like this right here, where if you're dealing with base e, like this log is base e, if I put an e in here, this just reduces to 1 over x. Now, let's look at an example here. So let's suppose that we've got the derivative of log base 3 of x. Well, here we go. This is going to be 1 over x natural log of 3, like that. Now, of course, all that we know about the chain rule, that all applies still to these logs. So let's look at one that we might need to use the chain rule. So let's suppose that we've got the natural or the log, let's say base 2 of 3x plus 1. Okay, and we want to find that derivative. Well, here we go. This is going to be 1 over 3x plus 1 log 2. See? I just took whatever's in there, I put it on the bottom. It had been x, right? Some of these others, like this one, it was just x, so I just put 1 over x. But this one's not x, it's 3x plus 1, so I put 3x plus 1 down here. Then multiply by the log base 2. Now don't forget the chain rule, because there's a 3 there. So I need to multiply by the derivative of the inside. So now we have our derivative to be 1 over, or 3 over 3x plus 1 log 2. And there's our derivative of that log function that it required us to use the chain rule.